Sure. Yeah.
Okay, so we're going to start with 2.5 axis milling. Um, and the part that we see here, the main thing we added, well, one of the things we added is cutter compensation for hole pocketing and profiling. I did just want to mention that if you have a hole that you need to cut and you need very tight tolerances, um, up to 6 or even higher if you need it, hole pocketing and profiling is the way to go. You can get very tight tolerances, like if you got a press fit or a loose fit, say of a bearing or a sleeve or something. This is the method you want to go to. And now that we've added cutter compensation, it makes it even better if you're cutting production holes or just if you want to use the compensation feature in your controller. But we've added cutter comp for hole pocketing. On the left, you see hole pocketing. On the right, you see hole profiling. And over here in the dialog, it works very exactly the same way as other cutter comp and other 2-axis operations. Just turn it on, and when you post, now I do want to make a mention of the post for cutter comp. Cutter comp does have to be set up in your post in order to output the G40, G41, G42, etc. In your G code file. So if you're posting and you're looking for it and you don't see it, just contact us or send us your post definition file, and we'll add those criteria to it and send it back to you. Okay, let's go ahead and start the demo portion. The first thing we're going to take a look at is 2-axis enhancements. So we've got a prismatic 2-axis part. It's got a bunch of holes. One of the things that we're going to show you here is the enhancements in both the hole pocketing and in the thread milling. So in this part here, we have an M40 metric thread that goes through the base of this part. And in order to start that operation, or prior to starting that operation, we want to clear out, rough out the material and get the inside diameter machined of that thread. So we need to do that ahead of time before we can do the thread milling. So let's go and look at hole pocketing here. So the first thing we're going to do is we're going to pocket out the hole and leave some allowance for the thread. So let's take a look at hole pocketing. Okay, so what we're going to do here was we're not going to select the whole perimeter, okay, because that doesn't represent the exact inner diameter of the thread itself. Okay, so we're going to select a point. Okay, we have selected a point right in the center. So we'll go on to the tool. So we're just going to use a flat mill, 12 millimeter diameter flat mill, to hole pocket this out. For the cut parameters on the hole pocketing, the enhancement in version 2025 that we mentioned is compensation. So now you can apply cutter compensation right or left on hole pocketing. So we got compensation set to auto on, and we've got other cut parameters set. A few that's of note here is make sure you select the location of your cut geometry. In this case, we have selected a point, okay, and that point lies at the top of the hole. It's not at the top of the part, as you can see, but it's at the top of the hole, and that is at top, okay? So also we have a hole depth that we just used the measuring tool to go ahead and calculate that depth. And we also have a hole diameter. Here's where I mentioned that we didn't want to use the diameter of the hole as modeled, because we want to make sure that we're cutting to the minor diameter of the thread, okay, which will be smaller in diameter than this hole itself. So we calculated that needed to be 39.796 in diameter. So that's the minor diameter of the M30 metric thread that we're going to be thread milling in that hole. Okay, so one thing to note, you want to make sure that you're using a point so you can specify the diameter. If you check this and use arcs for diameter, it'll just cut to the diameter of the hole itself, and that's not what we want. Okay, so what else do we have on here? Everything is pretty straightforward. We're adding a cleanup pass at each Z level, just to make sure we get the, as much accuracy we can get out of the whole pocketing. Now, the diameter of the whole pocket is not going to be the finished diameter. We're going to come back with the whole profile. So we can go ahead and go ahead and check that. That could be unchecked, but we'll leave it checked. Entry and exit. For typical for hole pocketing, we have a helical entry. So we got one helical entry at each cut level. So it's going to helical down and it's going to do a cleanup pass at each level. Okay, so we have a helix diameter of 1/4 of an inch, or 6.35, and then we have a height H of 6.35. Okay, sorting, we're not going to do any sorting, we're only cutting one hole. And then also in 2025 we have feeder optimization parameters. We're not going to use those in this case. Okay, so let's just generate that. So we have a hole pocket. Okay, we got one helical motion, and then we have a cleanup pass at each cut level. If you look at front, okay, you'll see that we have a helical entry and then a cleanup pass. The blue motion is a cleanup pass at each cut level. So there's going to be 3 cut levels. Okay. Okay, so that is the whole pocket. So that's basically a roughing operation for this M40 metric thread, inside diameter thread. So based on that, let's go ahead and simulate that. Since we're at here, let's go ahead and turn the stock off. Now you will find that we haven't done any other roughing off, so you're going to see this hole stick up a little bit higher. Let's go ahead and play that. Okay, so we got the hole pocketing. Let's go ahead and look at the profiling. So in hole profiling, you have one helical motion to the depth, full depth of the hole, and then a cleanup pass at the base of the hole. So this cleanup pass is what really zeroes in the accuracy of this hole. So this hole profiling, let's take a look at that. We're using the same point, the same tool. So in the cut parameters, we have compensation on again, and we have location of cut geometry similar to the pocket at top. Okay, and the hole depth is the same at 19 millimeters. And then also for the hole diameter, we're using 39.796. That is the minor diameter of the hole. And we're going to uncheck use arcs, and everything else looks okay. Entry exit, we got lines and arcs, so we got a 1 millimeter entry, linear entry, and then also linear engagement, a linear retract. Okay, and let's see, that all looks good. No sorting, no optimization. Let's go ahead and generate that. So here is our hole profile, if you look at it here. So this is the minor diameter of the thread. Okay, so keep that in mind. We're not cutting all the way to the hole. Okay, so let's go ahead and show you what that looks like. So if you look at this is the M40 hole here on each side, and this is the helical motion of the whole profiling operation. Then we have a cleanup pass, circular cleanup pass at the bottom. And again, we have cutter compensation enabled.